Hi everyone, good morning, good afternoon, good evening, wherever you are. We are back again with our DevSecCon India meet, and we have some varied sessions today. The first session being securing the applications which are in SDLC. And why do we talk about SDLC and why do we see these issues? So, when we talk about digital world, there are so many breaches which are happening. There's that data theft which is happening, and we want to do secure coding and whatnot. So let's hear from Animesh, who's going to share his story, his side of the story around SDLC. Even though we know about it, but then everyone has their own set of stories. So let's hear it from him. Hi, Animesh.
Hi Vanna, thank you all for joining in. I know it's a bit late. So coming on the point, the reason I chose why securing application is SDLC, the talk I'm giving, is because yeah, it's the software development market, right? Each day even in the with the introduction of AI, each day the software market is getting competitive and constantly dealing with errors, the data breach, especially the privacy and search concerns are arising. So let me just quickly share my screen and let me know if it's visible.
Yes, it's
Awesome.
visible.
Awesome. Thanks. So basically, there are multiple ways in which the SDLC in SDLC we secure our application. Now, why is it required? Why can't we do it after completing our application? Because when we have a piece of idea for either developing a software or adding a new feature in our current software, we generally tend to focus on the functional requirements and then we go to a complete other path. We plan again, develop, deploy, and maintain those changes additional at the later point additionally. So it's better that we write our security requirements along with this functional test so that we firstly we save our times, and the second most important part comes in that yeah, you know what is going wrong and at the same point you can fix it. So this is done through a multiple conventional ways. So first is utilizing the threat models that we are going to discuss about. Right? So what is threat model? So threat modeling is basically used for optimizing, identifying, and potential vulnerabilities that are currently present in our software. How it works? So threat model creates a structured representation of all informations of security leaks, threats, vulnerabilities that could happen in our software. And once it's ready, we actually use it to to get a clear line of sight across our project, which help us again in knowing the security issues that we currently have and how we can address them. So in short, it actually makes us it actually helps us in making rational decisions even before the coding phase has started. And this exercise basically guides us how, where, and at what places we need to add additional security to our CI/CD pipeline. So it's a modern day, right? No one is going to manually do everything and all. So it's a modern day of automation. That's why our CI/CD pipelines have come in a play and are helps everyone understanding how the threat environment in which the application will operate, what would be its response, if the response is higher or the threat level is higher, how should it behave and what all. So basically, we can implement threat modeling in four simple steps. That is, the first is identify what could go wrong, right? That's the step one. What are we building? The second comes enumerate threats, like as I said, what could go wrong, how the things are going to matter. Then comes mitigation, like once we have identified, okay, these are the threats that could harm our application or are creating a vulnerability in our application. How are we going to defend against these threats? What are the plans, programs we have already placed, and what are the timeouts, delays that we have worked upon? And then the fourth part comes in how we have acted in each previous steps, like what we are building, we have identified what we're building, the threats, and the protection against the threats, and whether they are in a proper place or not. So once these four steps are ready, basically you have a basic model that will help you to defend against different kinds of or give a report basically what could go wrong and how those things could go wrong. And the more we plan, the more these threats we actually think of, the better equipped we are if they actually occur. So here basically we are planning a use case scenario in which we are taking the worst case of what could happen, what could go wrong, and such.
Animesh, there's a lot of background noise. Even the dog is bark. Like I can hear the dog bark as well.
Yeah, just give me a second.
Sure. While he's coming, let me share some great resources around SDLC and the systems which are around it. So while we talk about SDLC, every like we talked about it, like um everyone has their own way of putting security into place and the way they want it to be. So there are certain steps that you should follow, and there are certain things that you should definitely check it out. Now I'm going to share a link with you where you can actually learn about secure coding and especially security for developers, where it's like a click through thing which can help you. So let me just put it in the comments so that you can go through it. So this is a free resource which is available at Sneak website, where you can go through these learning paths. It actually has all the vulnerabilities which can be there in the coding level. And as well as if you feel there's something which is missing, you can let us know. And we keep on improving it. We keep on adding few things to it. So it'll be helpful. Great. You can take it over.
Thanks. I hope there's a less noise in my background.
Yeah,
Yes,
that's right
good.
now. Thank you.
So yeah, I was going to talk about code scanning tools. Now, as I said earlier in the previous, the more we plan for and the more of these threats we come across, the better equipped we are when those threats actually occur in a real lifetime. Hopefully, it does not. So, although it is true that if we take vulnerabilities earlier in earlier stages of our life develop SDLC, it is cheaper, but we cannot rely on finding all the vulnerabilities during the development, right? Therefore, we need different kind of tools that can help us in concern solving this concern throughout the SDLC. So that's where the code scanning tools comes in. They analyze our code and tell us if okay there are certain aspects which could perform or which could make your application susceptible to attacks from either inside or outside or such cases. Now, why we are using those? Because they scale very well. You can use it in your locals as well as deployment or production phase as well. And the monitoring part that comes in, that's very helpful for us. So as soon as there is any breach, we can get alerts of or any issues if there is any bug. And that and second part comes in that we can smoothly slice through our source code, identify the potential security issues or the flaws that are going to arise or are going to arise. So here are a list of some scanning tools that basically helps us. Being check marks and synopsis being very popular, Fortify in the second. So these are a combination of different tools that works on a different methodology. Now there is not just one, but multiple methodologies that generally a developer or what should I say, a tester uh, uses for a complete SDLC lifecycle during their development part. So this category varies from SAST, secret detection, DAST, dependency scanning, IAST, RSAP, and something that is currently inbuilt but not being adopted is HAST. So let me go one by one what these are and how this works. So SAST is basically a white box testing. It's a static application during security testing. We say fancy words. but it's actually a white box testing. So what happens is we analyze our source code and we figure out okay what kind of possible security attacks could be there. But all this happens even before our code is compiled. So we scan and analyze our source code just after it's ready but not compiled yet, to go through okay whether there is any kind of issues that are going to arise, whether the whether any function is going to hinder from inside of the application, right? And then comes the secret detection. So nowadays we are heavily dependent on API keys and environment variables. So secret detection is basically a sort of I would say a method that helps us in securing that okay our application secrets are secure. A lot of times when we are building something, we generally hard codes our environment variable directly, whether it's an API key or such sort of things, and push it on a Git or GitLabs or Gitstream and such sort of things. So those platforms such as GitHub and GitLabs perform a secret detections. They check whether any secret variable is available and they revoke it. For example, if you have built a Discord bot, as soon as you have hard coded a API key from your application, and by mistake if it's pushed on either one of your versions, for example, it could be a latest version put, for example. So by mistake your API got exposed to the net. The Discord will identify, the GitHub will figure out okay this is the application key. This could be application from this place. And as soon as Discord is one of the list in one of the list, Discord gets a notification okay this was my API key by this person and it got exported, it would revoke it. So this method is generally automated. There's a lot less things that we have to worry about as a developer. But still, there is something called shadow admin, right? So when we're building something, we initially create some super admins or dummy login data. After it's live, we generally forget, or it is a very rare cases that we forget of deleting those, and they are still in place. So the hackers, they tend to use those hard-coded variables or the admin's access to actually get into your application, then hijack and intercept different things. Similarly comes the dependency scanning, right? So it helps us to automatically find security vulnerabilities that are in our dependency. For example, if you're using 10 different dependency, it could be some of the database, it could be some of other libraries that is being maintained by someone else. So in their link, so if those are not updated regularly, the patchwork or the security updates are not done regularly, it does not only create an issue for them but also for us, because we are using their last code or the last latest version, which does not support or is vulnerable to the latest attacks. So there is a bot called dependent bots, and if you are in an open source building something or from the open source dependencies or libraries, it is generally susceptible to vulnerability. It's being known for a variety of reasons that you have to update your dependencies regularly and frequently, because even if there is a loss, at first it could start as a low, but as the time goes on, if it's not updated, its threat level goes from low to high. Then comes the DAST. That's a dynamic application security testing. Right. It is also called the black box testing because in this from the attacker's perspective, we plan attacks from outside of the application. For example, it could be SQL injections or cross-site scripting and etc. So this happens while we are running an application. That's the difference between SAST and the DAST. Now, the major one that is being widely used is IAST, that's Integrated Application Security Testing. Here, we use the methods that are provided by both SAST and the DAST, right? So what happens is our application is in the static mode, but it's also running. So all the dependencies or the attacks perspective is from the DAST, and in normal static application, but the code is compiled. The last is the RACP. So RASP is basically runtime application self-protection. It is configured on a server and kicks in when an application runs. So it is designed in such a way that it detects attacks or an application in a real time. So when it begins, RASP protects it from malicious input or behaviors by analyzing both the app's behavior and the context of that behavior. So what prompts it got, and on that prompt, how is it behaving? Whether there is some kind of backdoor created or such and such sort of things. Now comes the CI/CD pipe tools. So this is the most important part if you are going to secure an application, as we cannot do the whole process multiple times and provide different tests, right? So what happens is the security control and the test are embedded early in the stage everywhere in the development lifecycle. So once we have created a security patch kind of thing, right? They need to be automated. So at every release or every part, as soon as even if it's a minor release, uh, all the security test runs and make sure that okay, there is no any vulnerability that could be exploited immediately, or that provides a high security threat. As all application, whether it's a small or big, whether it's a feature or a big software, they generally do tend to have a little bit of threats, because the dependencies that they are using or the models they are using outdates generally as soon as the cycle is over. There is something new that is always being created and in a work. So that's why CI/CD tools are. That's where CI/CD tools comes into play. So with this foundation in places, we can actually start to add security in our development cycles as well as planning, deployment, and the maintenance stage as well. So once our code is moving from our local to the cloud part, the testing stage is also compiled and approved automatically by the tools that we have planned or the logic that we have written accordingly. And these steps actually improves helps us in improving the security of the software cycle. Because once the application is over, and it's being generally in use continuously. For example, if it's in a current use, the next feature we are planning is comes after a maintenance stage. So after the latest deployment or the current deployment till the maintenance stage and till after that the further improvement, there's a lot of gap. That's why it becomes especially necessary that this test or the security is inbuilt properly in your application. Because if it's not, no one is going to focus much at all after it's been deployed and is in a public use, for example, at least 3 weeks, 4 weeks, or it could be a month. After a month, no one is going to focus, okay, what we are going to come back and check, okay, how this is working, whether there is anything um, explicitly present or not, until and unless there's a bug report. So that's when the post-release monitoring comes in, right? It is to basically monitor and detect and prevent the introduction of new vulnerabilities. So when our life cycle is coming to its end and it's been launched, there are multiple tools that we use to diversify the data sets into the reports, and then we figure out okay whether these thresholds are breaking or not, whether there is any problem or not. Okay, this was the scan in the production environment. Okay, this was the result. So we get a different kinds of report and then we match it correctly. So Grafana, Stackstorm, Detectify are one of the most popular tools that are being used uh, to at this point of stage once the deployment is done and we are moving to our maintenance stage. So that's all. That's all. If you have any questions, you can ask. Um,
Thank you so much. I don't see any questions at the moment. Probably they can reach out to you and
Yeah, you can reach out to
then
me at Twitter or LinkedIn. I'll be more than happy to, get in, and if there is anything that you're working around, and I'll be more than happy to, just connect with each other.
perfect. Thank you so much. Thank you so much, our listeners. We would be starting our next session in a while, so stay tuned for it. Thank you. Take care.